Development Lab, or FDL, is an applied artificial intelligence research accelerator, and we bring PhDs and postdocs from both machine learning as well as space science domains, and we pair them together to work on challenges in space science and exploration. And so today I am here with the automated reporting team. It is week 6 of FDL, and I am here with Noah, Vivesh, Vasiliki, and Fekshen. So really excited to have you all here, and you guys have an exciting challenge that we're going to discuss today. I'm really excited because this is one of the unique challenges, and it's unlike any of the other FDL challenges we've tackled to date. So this is really exciting. With that said, I would really love if you can walk me through the challenge that you're working on and why it's important.
Thanks, Sarah. Let me share my screen. Hi, everyone. We are the automated reporting team. I am Fekshen, joined by my teammates, Vivesh, Noah, and Vasiliki. And this is a great team of mentors, Piotr, Kevin, Dipsy, Kumar, Frank, and Rahul. I'll begin by showing a subset of natural events, the hazardous ones, which involve volcanic eruptions, wildfire, flood, hurricane, and drought that we have observed in the past. More concretely, next, let us take a look at a couple of examples of narratives with their accompanying images taken from NASA Earth Observatory. This image shows the northwestern part of the Caribbean island of St. Vincent before and after 2 weeks of volcanic eruptions, which began on April 9 this year. The brown scar in the vegetation in the image on the left was caused by damage from gases leaked by the volcano before it erupted its flame. After the eruptions, the fallout has coated large parts of St. Vincent. So what hazards this brings? Ash bombs from the eruptions pose a great threat to aircraft because the particles can damage jet engines, for instance. The ash layers can smother crops and taint water supplies. On the island, it was reported that large numbers of buildings were flattened and farms and infrastructure have sustained extensive damage. Note that the clouds of the tiny pulverized rock and glass shards have not only rained down on the island, but also the Atlantic Ocean. So what we can learn from here is that the impacts are certainly substantially global and are relevant to all of us. This was in Iraq, an image taken around April 2019, and this was before in 2015. There was a severe drought somewhere in 2018, followed by the unusually wet winter and spring of 2019, which had swollen Iraq's rivers, lakes, and reservoirs. Water levels in April 2019 at the Mosul Dam reservoir reached the highest levels in a decade. We can see how much greener the land surface was in 2019. It is important that we report these events to the public in time to increase environmental awareness and be informed of the state of well-being of our planet. In NASA, there are science writers who write about these events. However, with an increasing amount of data from the satellite images, it's hard for the writers to attend to all of the events. So the question we're trying to answer is, can we use natural language processing to generate informative descriptions of natural hazards and phenomena? We hope that our AI model could assist the writers to develop their work, and then these narratives could help raise public awareness of natural events happening around the world. So in a summary, if a phenomenon is first detected from the image, and the metadata of the event is stored in EONET, which stands for Earth Observatory Natural Event Tracker. So potentially there are many interesting stories to write about. And we hope to help create a system to automatically describe the events that will then reach the public. example of a narrative from NASA Earth Observatory. It contains the title of the event, the body narrative, and references used for the narrative. In the right column, there are location of the event, short caption, sensors used, which are related to the image, and topic words such as land, heat, temperature, extremes, etc. Our task is given the metadata of the events, namely the location, the title, short caption, sensors, topics, and etc. How can we generate narratives capturing these metadata? Why is this challenging? Essentially, we need to translate our table of metadata into narrative, and we need to perform a number of language model fine-tuning in order to bridge the domain gap so that we will have an in-domain narrative. Secondly, each event narrative is unique, not only in the context, but also the length. This poses a degree of difficulty in creating a diverse yet accurate narrative. For instance, earlier on, we related to volcanic eruptions. We saw an image of change in landscape within a month, and another image related to drought, the change of landscape over the years. So stories that capture such comparison are not straightforward to automatically generate. Thirdly, there isn't a single best evaluation method on a generated text to follow. So we are at the moment working to develop a tool for assisting writing procedure where it would reduce the processing time of new events. In addition, we hope to contribute to the NLP community by resulting models and evaluation framework for text generation. Thank you.
Great. Thank you so much for that overview. It is a really interesting and important challenge that you guys are working on. And I'd just like to do a little shout out for our audience members that are, it looks like Mexico, Oregon, Atlanta, San Francisco, Italy. Thank you so much for joining us. And if you do have any questions for us at any given point in time, just feel free to write to us, and we will see if we have some time at the end to be able to answer some audience questions. So that was a really wonderful overview. Now I want to dive a little bit deeper into the challenge, and this is really the first time that we're utilizing NLP, and I would really like to know a little bit about the techniques that you're using and what you guys have decided to do for the last 6 weeks.
Thank you, Sarah. I'll take that question. Let me know if you can see my screen. Okay, so hello everyone. My name is Vishwesh. So today I'm going to talk a little bit about the NLP and then the techniques that we have used. So the natural language processing is evolved from the computational linguistics and uses the methods from various disciplines such as computer science, artificial intelligence, data science to enable computers to understand human language in both written and verbal forms. Our problem falls within the domain of a natural language generation. Also, the natural language processes emphasis its uses of a machine learning and deep learning techniques to work together, and it supports the popular technologies such as chatbots or the speech recognition product like Amazon Alexa and Apple Siri. Moving ahead, now let's move to our approach. In order to solve the problem, we are going to combine the metadata information like location, date, sensor, etc., along with the existing narrative articles and with the use of a transformer-based model, which is a particular neural network that has proven to be remarkably effective for the common natural language processing task. And the research frameworks such as PyTorch Lightning, Hugging Face, along with the weights and biases for the analysis. And applying that, we will generate the descriptive narratives to any new natural event that is reported. And here the GIF is just a metaphor for the illustration. It has nothing to do with the Transformer comic or the movie. Okay, so for our research, we have opted for the generative pre-trained transform model, which is also known as GPT-2. The diagram provided by OpenAI demonstrates a bit of what this generative procedure looks like. Our idea is inspired by this former generation, where first, if we follow along here, the input is given, and each word is produced. That plus the initial input is used to produce the eventual output. Now to talk about our machine learning pipeline, the first one is the language model pre-training, in which we take the GPT-2 as our base model and fine-tune or just continue the training using the dataset that is provided by the NASA. And the language model fine-tuning will help to adapt the pre-training language model to new domain. Furthermore, the pre-training model will now become a base input for the conditional track generation, which will further fine-tune the language model using the event-specific data, and the model will select the next word using the probability distribution over the possible words. And currently, the team is working on model training and improvements, and soon we will be able to share the result with you. Thank you.
That's really exciting. Thank you for sharing that. And I know that you guys are working directly with some of the authors at NASA. What sort of things have you learned from them that you're incorporating into the work that you're developing for this tool that ultimately you're going to be able to provide to them?
Okay, I'm happy to answer that one. Let me just share my screen quickly. And confirming you guys can see this. Okay, great. So thank you for the question, Sarah. So as you mentioned, we've spoken to and are extremely grateful for the writers at NASA Earth Observatory for their help. And in particular, what we wanted to get from a conversation with them is a glimpse at the kind of steps that they take in order to create the informative and insightful reports or narratives that you can find on the Earth Observatory website. And the technical reason for this type of conversation is we wanted to understand as well as possible what runs through their brain, and is there a way for us to emulate this sort of process as we create our machine learning models to make them emulate as closely as possible the types of narratives that they're able to produce. And the first part of this conversation centered around their research. And what I mean by this is we wanted to understand what inspires these writers. And by that, I mean what makes them choose the stories that they do. And then once they've already selected a story, where do they collect the facts and data that they use that they present within the story? And what I'm showing on this slide is a list of some of the reputable sources that they use. And essentially the writer collects facts and other information from these resources, and then distills that information to the broader audience through the Earth Observatory narratives. And then that then comes to the second part of our conversation with them, which focuses on narrative elements. And what I mean by this is basically how do they turn their story into something that is as enjoyable and informative as it is on the website. And that comes from these certain narrative elements, which are sort of encapsulated within the story. There's four main elements, which I'll touch on below, which is the general phenomena description. So this is just a brief description of the event. So what it is, how strong it is, and other details like that. The societal impact. So this might be information associated with what towns were affected, how much damage was accumulated from the storm, and things of that nature. The scientific impact. So this then relates to climate change and other sorts of scientific details that might be related to the event. So is it tied to any other natural events that have been occurring recently? Is it a record-breaking event? And again, things related to that. And then lastly is the spatial description. So this is going to be more information about the location which was affected and perhaps how the landscape has changed as a result. You'll notice that these circles are overlapping. This was an intentional decision and just meant to indicate that even within the same sentence of a story, it's quite possible that you could have one or more narrative elements encapsulated within one. And then on the right is something which we're also considering including as part of our automatic descriptions, but is not so related to what's currently on the left, which is sort of what relevant NASA data might be useful for follow-up from an event. So the way that we foresee this being useful is you can imagine someone who's very interested in whatever the story was, now has access to the available NASA data that could be related to the event that happened, and perhaps that person would like to play around with the data or make their own sort of discovery about the phenomena. So that sort of summarizes what the conversation was, and like I said, it sort of gave us an idea as to what we want to encode into our machine learning model. And this can sort of be presented with the blueprint of these two bubbles, which are shown below. So first touching on what those narrative elements were, what the conversation told us was we need to find a way to incorporate as an input to the machine learning model is somehow to capture these narrative elements. And that means we need a input that somehow is able to tell to tell the machine learning model as it produces its narratives, what is this paragraph or story about? And then preferably, can that sort of input also be sure to incorporate at least one of the narrative elements that we've just discussed. And then on the right is the research. So again, if you want these stories to be informative, they need to incorporate some sort of facts. And that means we're going to need to find a way to incorporate as part of the machine learning model's input, details like the location, the date, and then event-specific information. And on this next slide, I can show what our current approach is for this. So in an offline setting, meaning where the narrative is already present, you can see it's pretty possible to extract the sorts of summaries and keywords which are going to be very essential to understanding those types of information. So on the top of this slide, you can see a bubble. This yellow bubble is a just example narrative from the Earth Observatory website. And you can extract a summary using some automatic tools. And this automatic tool can help us understand what narrative elements are incorporated as part of this. So in this one sentence summary, which is going to serve as an eventual input to our machine learning model, you could reasonably kind of assume that, or you can reasonably understand that this input encapsulates the general phenomena description we just discussed, as well as a little bit about the scientific impact. So you can see that an instrument is mentioned as part of it. And then on the bottom, you can see, again, using an automatic tool, we're able to extract a very similar fashion of keywords and facts that are going to be essential to the retelling of this story. So you can see below are in highlighted. These are some of the automatic words that are extracted and will all serve as essential inputs to our machine learning model, which we'll be happy to present later on. Yeah, thank you.
Awesome. Thank you, Noah. And thanks for showing that example. And Fexen, you also showed an example of some of the data that you were using at the very beginning, but I'd love to hear a little bit more about the data that you're using and where those other data sources are coming from as well.
Sure, Sarah. Thank you for your question. And I am happy to address it by sharing my presentation about the datasets. So hello, everyone. I am Vasiliki. And in these slides, I'm going to elaborate more on the datasets. So our dataset pool is constructed by multiple heterogeneous text sources. So our main source of data is provided by the NASA Earth Observatory and its narratives, along with some metadata about additional events, about natural events. Also, we do have a small data set provided by the Planet Labs, which actually a short description of satellite imagery along with metadata. We do have also Earth Science Corpora that is composed of the Astrophysics Database System, which is a collection of academic literature and research papers that is for relevant natural events and disasters. We also do have academic abstracts from the American Geophysical Union. And we can see from the pie chart on the left of the slide that this AGU data is actually the majority of our whole data sets. And also, last but not least, we do have the Common Metadata Repository, which is a metadata system that associates Earth science datasets along with metadata records and natural events. Now, let's elaborate more on the Earth Observatory data, which is our main dataset. So its size, it's 14,000 samples. And saying samples, we mean 14,000 events that are reported in the Earth Observatory site. In the right side of the slide, we can see an example of of an article in the Earth Observatory. We can see the imagery along with a narrative that describes what's going on in the image and provides additional context about the event, about the natural event. We also see attached some references that actually are provided to the readers for additional information. We do have the title that gives a short description of the event. Here in the globe, with the red dot is represented, is actually the location. And following, we can see the short caption here, which is actually one or two sentences that provide additional context about the event. We do have a list of sensors it's actually the sensors that we use so as to capture this imagery. And also we do have a list of topics that describe this event. So for this specific example, the topics can be heat, atmosphere, and extreme temperatures. And last but not least, we have a list of events that are relevant to this specific event. On the left side of the slides, we can see how we access actually this metadata. So we do have the title, the short caption. Also, we see that the location is expressed using the coordinates, and we use reverse geocoding so as to obtain the location in a textual format. We also do have information that we don't use in our research, as that's the post date and thumbnail file. As I said previously, in the Earth Observatory data, its sample is characterized by a list of topics. And from this list of topics, we can understand what type of natural disaster we do have. So some examples is drought, heat, storms, fires, volcanoes, floods, earthquakes, and landslides. And from this histogram, we can see that storms, fires, volcanoes, and floods are actually the majority and are well represented in the dataset. Also, in this Earth Observatory dataset, we apply some techniques so as to extract more information from the narrative. At first, from the narrative, we extract the title and the short description. Furthermore, we divide its narrative to its paragraphs. And to each paragraph, we apply a technique to obtain the summary. And also we apply also a NLP model so as to obtain some keywords. And these keywords represent some entities. So it can be location, it can be a date, or it can be like an object, such as, for example, an additional sensor that were used, or it should be mentioned in the paragraph. And we use all this additional information so as to further develop our research methodology. And that being said, actually, this concludes our our data pipeline from the collection and accumulation from the heterogeneous data sources to the information extraction that we do apply. I hope this addressed the data question. Thank you.
Yeah, that definitely did. And it's great that you guys are pulling so much information from all of these different data sources and being able to use it for these narratives. So I was lucky enough to be able to see what you guys were working on Friday and see some initial results. And I was wondering if we could share some with the audience.
Yes, Sarah. Let me share my screen. Yeah, so we would like to share with you an inference result from an example of a volcano event. We consider 4 inputs to our models: title and short captions from the metadata provided, and additionally keywords from the full text that we extracted using named entity recognition, as was very well explained by Vasiliki just now. And lastly, a summary that we generated. So we are interested in generating a narrative in terms of paragraphs. Here's the first paragraph from this bold text at the bottom, and this is a summary generated from the first paragraph. It happens that in this summarization example, the summary generated is the first sentence of the paragraph, but this is not always the case. So, conditioned on the inputs, which are title, short caption, keywords, and summary, here's our first results using beam search decoding, which outputs most likely sequences. On the left is the ground truth text, the first paragraph. In the center is a generated text by a conditional language model, which is not pre-trained on our data sources. On your right, the model is pre-trained on our data sources and conditioned. So highlighted in red are the sequences which also appear in the ground truth text. In red and in italic are sequences which also, in red and in italic, we see how summary is generated, how the generated summary is incorporated in a narrative generation. Underlined are the keywords that we extracted earlier on. So interestingly, although they do not appear in the ground truth first paragraph, they are actually contained in the following paragraphs in the ground truth full text. The crucial point here is that we notice an obvious model hallucination in the conditional language model, where the stated year 2017 is wrong, while from our pre-trained and conditioned model, it correctly captures the year 2021 when the event took place. So this shows a promising first result. At the bottom are some metrics used to evaluate our generated text, the blue scores, and a couple of Rouge variation scores. The Rouge LF score from our pre-trained plus conditioned model is slightly higher than the one from our conditional model. Thank you.
Great. Thank you so much for sharing some of the initial results. And you guys still have a few more weeks to go. So looking forward to what you guys end up with, but very promising. So now I'd like to shift questions for the whole group here. And I'd love to know why you are personally interested in this challenge. And we'll just kind of go round robin. So Vasiliki, would you like to kick us off?
Yeah, sure. I think that our challenge is not your everyday NLP problem. Its difficulty and uniqueness lies behind on the data that we have, and also the limited data sets that we have in the earth science domain. So also we know in general from the NLP field that natural language generation, so generating free text, is a hard task, and since the evaluation of this generated free text is still an open research question in the community. Also, our challenge has great potential, I think, for both the NLP community and also the earth science, and the combination of the above actually is what motivates me and what I find interesting in this challenge.
Thank you so much. Yeah, the interdisciplinary of this challenge is just really, really awesome and unique. So, Noah.
Yeah, definitely echoing what Vasiliki says, but I guess I would almost say even just like one step back of just, I haven't really had much experience using natural language processing. I have a ton of experience using machine learning. So it was just a great like opportunity to really like test my skills in this new domain, or I guess data set. And then as well as just the fact, like much like the FDL is in general, like the idea of applying it to a pretty relevant and interesting problem that is like the earth science related narratives.
Thanks, Noah. What about you, Vispesh?
Yeah, I agree on whatever is said. But for me, I would say, since we all know like how much in general the machine learning field has grown, especially in NLP domain, and many applications are leveraged on it. And especially in this challenge, particularly, it's not only how we apply these techniques, but also to understand how these state-of-the-art models can be utilized to solve the problems from the different domain, just like ours. And moreover, the data that the NASA has provided itself is unique and challenging, and it just keeps us motivated as the research is going to help the writers and eventually automate their process efficiently.
Great, thank you. And Fexen?
Yeah, similar to what the team has said, neural language generation is a challenging research area. And for instance, an automated evaluation of the quality of the machine-generated text, which is also part of our workflow, is an active research itself with so much room for improvement and exploration, hence the excitement. Moreover, it'll be amazing when this could potentially assist NASA science writers in their work, and many more narratives could reach the public. And on the other hand, though text generation is an automated process, it's intriguing to see how far it can go in, say, creative writing.
Great. Yeah, that's a really awesome perspective. So we've also been through 6 weeks of FTL together, and I know that I've learned a lot. I would be interested to know from each of you what the most interesting thing that you have learned during this time together. So I don't know who would like to start here.
I can go again.
Great.
So FDL brings together people from diverse backgrounds like computer science, engineering, earth science, space, and health science. And I strongly believe that having diversity is also is equal to power. So I would say that except from all the technical things and the research papers that I have go through and that have provide me more knowledge about the NLP, I think that the most interesting thing that I have gained so far is all the tips and the advice that we share with each other. So you can have an idea and advice from another researcher from a different domain. So finally, you have the chance to see a specific problem from a different total point of view, and that's really interesting and exciting, I think.
That's really great. Yeah.
So I'll just add something on that. So here in FTL, like since we all researchers come from the different backgrounds and we bring the a unique experience to the table, and along with our amazing mentors and their expertise, when they come together, and the way we work as a team to address the problem is something very valuable experience that I have gained. And I think it makes all of us, very proud to be the part of this extraordinary journey.
Thanks.
Yeah, I agree with the team. I come from a background in theoretical and mathematical physics. Although I had a prior research experience working in natural language processing before joining FDL, it still amazes me how computer scientists, that is my brilliant fellow teammates and mentors especially, approach and solve a problem.
Thanks, Noah.
Yeah, and of course, agree with everything my teammates just said. And then on top of that, I would add, it's been a pleasure to sort of learn more about like the different tools that we've had to use throughout the program. And I'm excited to see how it all works out. But yeah, things like using Google Cloud, and then the things listed by Fishfesh on his slide, like Hugging Face, PyTorch, and things of that nature. It's been a lot of fun to sort of debug and figure out how to use them.
Thanks. Yeah, I mean, it's been a really great experience working with you guys as a team as well. So I wanted to take a question from the audience. And I'm hoping that you guys can kind of take it in the direction that's applicable for your project. So how long would it take for a detected event to be used by the models, and are they made available from the sources within a reasonable amount of time? So I know your pipeline is slightly different now than what it could be, and if you can just kind of talk a little bit more about how that pipeline process works, that'd be great.
I can go on with this for this question. I think that natural events are like stored in the database like every day, and from these all the natural events that they do happen and they are stored like every day, the writers only provide narratives for a single one of them. So since we do have access in this database, we can like easily augment our data set every single day with every new event that is added in the database. And that's does not take long, if this addresses your question, the question.
Awesome. That was, yeah, a really wonderful answer. So I think we're nearing the end of our time. And I know you guys are busy finishing up FDL. So I would just like to say thank you so much for joining us today. That was a really interesting challenge that you guys are working on. And thank you to the audience for joining us. And I look forward to joining the Solar Wind FDL team tomorrow. So stay tuned. Thanks.
Thank you, Sarah, for having us.
Yes, Sarah.
Thank you, Sarah.
Thank you, everyone.
Thank you.